Welcome to the first videos of the chemistry tutorial. To start off, we're going to begin with the concept behind the mole. So basically, what is the mole? And also, what is molar mass? What is the purpose of it? So to start off, we're going to start with a very simple reaction. Very simple. Sodium plus chlorine gives us sodium chloride. So say you were going to actually do this reaction in the laboratory. So you're going to go in the lab, you're going to get some sodium, you're going to get some chlorine and make sodium chloride. An amateur at chemistry would say, okay, I'm just going to get 1 gram of the, oh yeah, I forgot, I have something I can point with. 1 gram of the sodium and 1 gram of the chlorine and get maybe 2 grams of the sodium chloride. But that is completely wrong. And the reason for this is because you have to remember that when this reaction, 1 atom of the sodium reacts with 1 atom of the chlorine and gives you 1 molecule of sodium chloride. And you got to think about, like, what do these atoms consist of? So if we think about the sodium atom, let me change colors here. So if we think about the sodium atom, you have to remember it has 11 protons, and we could say 12 neutrons. And then the chlorine, well, it's going to have 17 protons, and we could say 18 neutrons, so for a total of 23 and for a total of 35. So, and remember, these numbers I just came up with, that's what the atom consists of. This is the weight. This is the weight of the sodium atom, and this will be the weight of the chlorine atom. So each of these different atoms weigh differently. So we're to get 1 gram of the sodium compared to 1 gram of the chlorine, we would not have a equal number of atoms. So it wouldn't make sense to get 1 gram and 1 chlorine. We need to get the same number of the sodium atoms and compared to the same number of the chlorine atoms, and therefore we'll get the same number of sodium chloride molecules. So as you can see, general ways of measuring the amounts of the atoms do not work very well, such as grams and volumes, or such as liters. So this is when we need to think of a better way to measure how many atoms we actually have. And this is how we came up with the mole. So basically, in very simple terms, let's change colors. They say that 1 mole is equal to 6.022 times 10 to the 23rd atoms. And this number is very big, and there's a method on how they came up with this, but the reason why this number is so huge is because atoms are really small, and we can't weigh out individual atoms. So they just they make a very large number, and it's something that we can work with on actual scales inside the laboratory. So 1 mole is equal to 6.022 times 10 to the 23rd atoms. So let me go to the next slide. Okay, so like I said, 1 mole, that equals 6.022 times 10 to the 23rd atoms. Now if you look at the numbers in your periodic table, those masses such as hydrogen would be 1.008, and then let's talk about what we were doing before. Sodium would be 22.99, and then chlorine would be 35.453. Now these numbers all have meanings. They're not just on the periodic table for no reason. These numbers right here, this is the amount of grams that 1 mole of hydrogen weighs. So therefore, sodium, 1 mole of sodium weighs 22.99 grams. Chlorine weighs 35, or 1 mole of chlorine weighs 35.453 grams. Okay, so if we were going to go back to the original equation we had before, with the sodium plus chlorine gives us sodium chloride. Instead of weighing out, okay, instead of weighing out 1 gram of sodium and 1 gram of chlorine, we'll get 1 or 2 grams of sodium chloride. We're going to weigh out 1 mole of sodium and 1 mole of chlorine, and that will give us 1 mole of sodium chloride. So I hope all of this is making a lot more sense now. The molar mass, say again for like hydrogen, 1.008. The molar mass is the amount of grams per 1 mole for hydrogen. It's very specific for hydrogen, and the reason is one hydrogen, like say the difference between hydrogen and helium. The molar mass of helium is 4.002 grams per mole. Units are important. So these molar masses are very specific to whatever element we're talking about. And the reason is because, remember, the mole is equal to, 1 mole is equal to 6.022 times 10 to the 23rd atoms. So 1 hydrogen atom has 1 proton, and then 1 helium atom has 2 protons and 2 neutrons. So the helium atom weighs a lot more. So if we were to have 6.022 times 10 to the 23rd atoms of hydrogen, it will weigh a lot less than 6.022 times 10 to the 23rd atoms of helium. And just to make sure that it does make sense, so let's say hydrogen, 1 mole. No, let's do a different one. Let's see. Let me erase some stuff. Yeah, that's pretty cool. Okay. Let's do green. Alright, so let's pick another atom in there. Let's say carbon. Carbon, that's a good one. So you look at the periodic table, you look at carbon, and you see that its molar mass is 12.01 grams per mole. Very important that you memorize that. Molar mass, the units of molar mass is grams per mole. So what does that mean? Well, like I was saying before, the molar mass is the amount of grams per 1 mole. So we know in 1 mole of carbon there are 12.01 grams. So we had 2 moles of carbon, we would have 24.02 grams. Alright, this is making sense. 3 moles of carbon, that's going to weigh 36.03 grams. But say we had half a mole of carbon. Yeah, that would weigh 6.005 grams. So molar mass is just basically a constant for each different element, in which it tells you the amount of grams per 1 mole of that element for whatever you're talking about. In the next video we'll do some conversions between moles and grams, and then back from grams to moles.